Okay, number 7 on the McGehee problem set. Now look, first off, this diagram, it's pretty awful, man. I added right here distances not to scale. So like, look, this right here, this is pretty poor. This is 15, and then that's 12. It's like, what's up with that? Just, I apologize, not to scale. I bet that was done just to make you think extra hard. Okay, so Tarzan swings from a 15-meter vine attached to the limb of a tree. So he begins his swing 12 meters above the ground, and his lowest point is 2 meters above the ground. Now, part A, we're assuming no friction, which means it's completely conservative. Here's the master equation. Let's just start by going through the master equation. So up here is the initial. Let's call this point A. And then the lowest point in the swing, when Tarzan passes this point right here, let's call this point B. And you know what, guys? Let's just move the 0 point. The 0 point does not have to be the ground. Down here, in fact, I would not make this the 0 point. Where's the lowest point for Tarzan's motion in part A here? Right there. This is going to be our 0 point. For measuring what? What gets measured off the 0 point? H for potential of gravity. MGH. H gets measured from the 0 point. Okay, so that's the 0 point. Let's go through the energies. Up here at point A, at the start of the problem, does Tarzan start with kinetic? Is he moving at the start of the problem? Nope. Potential of gravity. At point A here, does he have potential of gravity? Yeah, because he's above the 0 point. Okay, is there any spring energy? No, that goes away. Next one, work non-conservative. Now what is work non-conservative? It's the work done by any force other than gravity or spring. As Tarzan moves from point A to point B, there is only one force doing work. What's the force doing work from point A to point B? Gravity. Now, I've heard it many times where kids say, well, what about the tension in the rope? Doesn't the rope exert a force on Tarzan? Tension would be pointing that way. Yeah, but notice at every single point, the tension is perpendicular to his motion. Forces that are perpendicular to the motion do no work. So the only force doing work from A to B is gravity, which means what about this? What's work non-conservative? It's gone. We don't have one. The only force doing work is gravity. Now, point B. Does Tarzan end with kinetic at point B? Down here now. Point B. Yes. Does he have potential of gravity? No, because he's on the 0 point. Does he have spring energy at point B? No. So what we're left with is potential of gravity initial at point A is going to be converted to kinetic final at point B. So now you plug in the equations. MGH equals 1/2 mv squared. Okay, about 5 kids this morning pointed out to me that the mass was not given. If you come across a problem where mass is not given, what does that tell you? It's going to cancel. It doesn't matter if he weighs 100 pounds or 500 pounds. Mass cancels. Okay, so what we're left with is velocity is going to be equal to square root 2gh. That's going to be 2 times, I think McGehee used 10 on this worksheet. So 10 meter per second squared. And then what's the h going to be? Is the h going to be 12? Because we subtracted away this 2. So the h is going to be this distance here, which is 10. So that's 10 meters. So this comes out as 14.1 meter per second. That's part A. Now, any questions on that? Part B. Okay, if 10% of Tarzan's initial mechanical energy. Now, dudes, for this problem, I'm going to put the 0 point back down here, and I'm going to tell you why. I'm putting the 0 point back down here because it says right here, how high above the ground. They want it above the ground. So let's just put the 0 point back down here. Now, again, here's point A. Now for this problem, point B is going to be when Tarzan comes up like this, and for a split second he stops, right? The velocity here is going to be 0, and what we're looking for is this height here. We'll call this HB. So over here, this will be HA. So we have height A, height B is what we're looking for. Okay, so let's go through the energies again. Does Tarzan start with kinetic at point A? No. Potential of gravity at point A? Yes. Spring energy? No. Any non-conservative forces doing work? No. Does Tarzan, so now let's look at point B. Point B right here. Does Tarzan end with kinetic at point B? Because at the highest point, this problem's talking about, where right here, how high, so we're looking at the highest point above the ground. For a split second, he stops, so there's no kinetic. Does he have potential of gravity over at point B? Yep. And then does he have spring energy? No, there's no spring there. So what we're left with is potential of gravity initial is equal to potential of gravity final, but hold on a second. What did they tell us here? 10% of the initial mechanical energy is lost. So if you lose 10%, how much do you keep? 90%. So basically, so this is going to be potential energy. Here's how you'd want to set this up. I think this is the easiest way. So is this true right now? Potential at A equals potential at B? Is that true? Because he lost mechanical energy. Okay, so what's going to be true is this. The potential energy at B is going to be equal to 90% the potential energy that he had at A. I think that's the easiest way to look at it. He keeps 90% of his mechanical energy. So what type of energy did he start with over here? Potential. What does he end with over here? Potential. Are those going to be equal? No, because the problem tells us he lost 10%. If he lost 10%, he keeps 90. So now we go MGHB is going to equal 0.9 MGHA, and then the MGs drop out. So HB is going to be 0.9 HA. So you're going to go 0.9 times 12 meters, which gives 10.8, and then that's measured off the ground. So you're good.